Okay, so the last page, front and back, it's just a variety of things. Here we are writing systems of equations. So this is the easier version of writing them when they give you the 4 equations. I don't have any on today's assignment where they give you the word problem and they don't give you any of these. They just say, hey, how many adult tickets were there or how many children's tickets were there? In which case you have to write both equations without being able to see any, put them in the calculator and go see where they intersect and pick out which of the numbers was the adult. Did you make the X the adults or did you make the Y's the adults? So anyway, those are the harder versions, but these are a little bit easier ones where you have the equations down here to look at. So the Mendez family is going to see a play, so you know you're writing the systems. The adults cost $9 and the children's are $6. There are 6 people in the family, so here's my one total. My number of tickets total is 6. They spend a total, here's my money, of $48. So each of these totals is going to make 2 different equations. We have the money equation and we have the number of tickets. And they're using A for the adults. So A is my adult, if I want to write it where I can see it better. And C is my children, or all 2 childs, right? Okay, now how much did an adult cost? $9. So 9 goes with the A. If they have anything with a 9C, get rid of it, it's wrong. And there were $6 for the kids, so 6C goes together, all right? So this is my money for the adults, my money for the kids. If you add them together, they should equal $48. So let's go look at our 48. 9A, 6C, yep, there we go. 9A, 6C, 48, yep. 6A, wait a minute, it wasn't 6A, was it? No, get rid of that. Whole set is gone. 9A, no, this says 6A and 9C, so those are gone. So those 2 we got rid of, which is that first equation with the money. Now, how many tickets were there all together? I had my adult tickets and my children tickets, and all together, how many people were there? 6. So between the adults and the kids, all together there were 6 people. So A plus C should equal 6, not that thing. So there's your answer right there. Hey, voila. So they're a little bit easier when they're like this. So a box contains 22 coins. There's my one total. And consisting of quarters and dimes, so they tell you what they are. And the total money is $3.55. So there's my 2 equations. One is going to be the total of coins. One's going to be the total money. Now remember, Q's and D's for dimes. Q's, if you've got a Q, how much is a quarter worth? It's 0.25, okay? It's not 25, it's 0.25. And then dimes are 0.10, so the 0.10 should go with the D's. Had they had nickels, and I'll write down nickels for you. There were no nickels in this one, but if there were nickels, nickels are worth 5 cents. That's 0.05, okay? Not 0.5, not 5, but 0.05. So had there been nickels, you would have used the 0.05, but we don't have that in today's. So 0.25 goes with the Q's, 0.10 goes with the dimes. And how much money is there all together? $3.55. So if I add these 2 piles of money together to the plus sign, it should equal $3.55. So here's my $3.55. 10D, wait a minute, they're not worth $10. No, so it's not that. 10 cents for a dime, 25 cents for a quarter, $3.55. That one works. 10D again, no, it's not worth $10, so get rid of that one. 10 cents for a dime, 25 cents for a quarter equals $355. I don't think so. And then, of course, on this one, the number of dimes and my number of quarters equal 22 coins, so B was the right answer on that one. So these are not that bad to do. You can do these. These are considered some of the harder questions on the STAR test, and y'all can do these. All right, so if you've not done a few of these, go try them on your own. This is a double table. Again, it's a system. They say, Greta made a table below for the systems of equations. So here's the 2 equations, and this is the table they make. This is the X for both equations. So this is X for the first one, and Y for the first equation. So this is your X and Y, one table right there for one equation. Now the second equation, this is the Y's for the second one, which means if you ignore this first table, the X's are there on the left and the Y's are on the right for the second equation. Okay? So what you're looking for is if it's a solution, they're saying, what can Greta conclude from the table? And they say the solution of the system is this, or the solution is that, or the system has infinite solutions, or there are no solutions to the system of the equations. So remember what infinite means they're on top of each other. If they're on top of each other, both equations should have the exact same table. When X is -3, this one has a -8. Is this one also -8? No. So are they on top of each other? Is -5 and -5 here? No, they're not. So it's not this one, which means it's not infinite. No solutions means the 2 lines are parallel, and there's no points that are on both tables. So this is -3, -8, -3, 0, different points. -2, -5, -2, -1, 2 different points. -1, -2, -1, -2. Oh, wait a minute. Didn't I say that twice? -1, -2, -1, -2, Yes, this point right here, in the first equation, it's -1, comma, -2. In the second equation, it's -1, -2. So that point is on both lines. So that means it's not parallel, because I do have, so that means these things are intersecting, and that one point is where they intersected. So that, where they're the same, is my solution. So let's go see which one it says. The solution is at -2, -2. Nope, it was at -1, -2. That's the point that's the same on both graphs. Okay, x and y for the first one, x and y for the second one. All right, it's just knowing how to read a double table. Once you get used to reading a double table, these actually become very easy. This one, the question, no question down here, it says, which is the best solution, if any, for the system of linear equations shown below? So here's my system with two equations. Are there any solutions? They never intersected, did they? No, so there is no solution. They're not on top of each other. They're separate. They're parallel. So is there a solution? No, there are no lines that are, there are no points that are on both lines at the same time. Which inequality is represented by the graph? So here's my 4 inequalities, and here's the lovely picture. Problem is, are any of these in y equals format? No, they're not. Bummer. But before I start solving these for y, notice this is a solid line. So get rid of anything down here that does not have a line underneath the symbol, because these make solid lines. So is this making a solid line? No, it would have been a dashed line. Get rid of it. Solid line, yes. That one should be a dashed line. Get rid of it. Solid line, yes. So I had 2 equations that I'm going to have to solve for y and see which one matches this. So let's just do one first. So on this one I'm going to solve. I'm going to get minus 3x on both sides, so this is going to be my minus 3x on this side, so minus 3x on this side is gone. If I rewrite this, it's 4y is less than or equal to, now don't flip it because I'm subtracting, and I don't flip it when I subtract, negative 3x minus 4. Okay, now I need to get rid of the 4, so divide by 4. Dividing by a positive number, I do not need to get rid of it. Oops, it's not negative 4, it's positive 4. I don't know why I put negatives down there. I guess because I saw these negatives up here when I was writing. So I'm dividing by a positive 4 on both sides. So y is less than or equal to, and this is a negative slope, 3/4 x, and this is minus 1. So it's crossing at -1, check. Negative slope, yes. This is, y's are less than, that means I'm shading below. Did we shade below? No, we did not. It is not that one. So at this point, if you just want to go ahead and pick D, you can, but if you want to solve it, you can. And when you do solve it, it's going to be saying that y's are greater than or equal to, and so it will work out when you just, yeah, you don't have to flip this one either when you're solving, because you're going to divide by a positive 4. So anyway, D does work, but if you want to solve it just to be sure, you can. But it was the last one that didn't work. Let's see what else we have here. Now, if you haven't done some of these, go ahead and try them. Pause the video, go work a few, and then come back and check your answers. Again, we're matching these two inequalities to the pictures. The problem is we can't graph inequalities. So the shade up, shade down, and all that lovely stuff. Solid and dash. This is a dash line, and this one's a solid line. So I need one dash and one solid. One dash, one solid. Oh, look, that's 2 solids. Get rid of this one. Oh, this is another 2 solids. Get rid of that one. One dash, one solid, yes. So now I just need to look at the shade up and shade down, because they both come, this solid line looks like it's really identical to that, crossing at 2, yep. This dash line seems to be going the exact same place, and it looks like they're intersecting at the same place. So both pictures have lines in the exact same spot. It's just this is saying this is the double shaded area, and this one says this is the double shaded area. So we just need to go check the shading. This one, which is the dash line, so focus on the dash line, right? Here's my dash line. They are shading above or below. The y's are on the pointed end. That means my y's are smaller. Which way do y's get smaller? Down. So I'm going to shade below this dash line. So that means I'm going to take where that dash line is, and I would shade this whole side over here. Is there anything shaded anywhere at all on this side of the line? No, so I'm thinking this is not the right one. Let's go try this one. So here's my dash line, if I can get it to stay. So I would have shaded below. So this has a little piece over here that's shaded below, but they would have shaded this whole thing below. And then on the other one, the solid line, the y's are bigger, which means I'm going to shade above. So here's my solid line shaded above. So if I shade above on this side, that means I shaded above. I'm going to kind of draw lines over here. So I shaded that side of that one, and I shaded this side of this one. Notice where's the double shading? That little corner, that's why they double shaded. That's why that the part shaded, they're showing the double shade. So this is the piece that was shaded in both of them. So this does match it. It is B. So shade up, shade down, solid or dash. Those are your go-to. And then, of course, you can also check out the y-intercept and the slope numbers to make sure they're going the right direction. Another set. checking for which picture matches it. But again, you can't put them in the calculator. Oh, and none of these are in y equals. Okay, so let's just go look for, first of all, remember dash line, solid line. Get rid of the easy stuff. These are both dash lines. They're not both dash lines. Get rid of that one. Only one dash line. Get rid of that one. Oh, that one's got both dash lines. Hey, this one has a dash and a solid. What's the only one that had two dash lines? Sometimes you get lucky and you don't even have to solve for y. So go with the dash and solid first and eliminate answers. Okay, if you have not done the back page, go try it on your own. These are a bunch of easy ones, and then come check them with me. So pause the video if you need to. Go do them, then come back. Now, we want to write the equation. Here's my 4 equations. Now, you could literally go graph these equations and find one that looks like this. The other way you can do it is you can say, oh, this is a horizontal line, right? If it is a horizontal line, I'm going to write H-O-Y, H for horizontal. H-O-R-I-Z-O-N-T-A-L. That's how you spell horizontal. It starts with an H. So, HOY, the slope of this line is 0, and the equation starts with y equals a number. This is y equals, but it's not just a number. This is y equals a number. This is x equals. This is y equals, but not just a number. So it's saying y equals -4. Here's my x-axis. -1, -2, -3, -4 is my line going through -4 on the y-axis. It is that. And I would check it. Put this in the calculator. Make sure it looks like that picture. You can always just put it in the calculator and check the picture. You can't put the x equals in, though. That's the problem with those. All right, this one. This time it's a vertical line. It's not my horizontal, so I'm going to write the word bucks. The slope is undefined because it starts with a U. Remember, this one was 0. Slope is 0, and y equals is the number. This is slope undefined and starts with x equals a number. But they asked for slope, not the equation, so the slope is undefined. It would be A. There you go. You could also do the little song. So if you do the little song, you can hold a pencil, and you could say 0, positive, undefined, negative. Maybe I should get out further. 0, positive, undefined, negative. 0 flat, positive going up, undefined straight up, negative going down from left to right. Yep, that little song. All right, use the quadratic formula to solve. Do we have to use the quadratic formula? No, we're just going to solve the equation any way we want to. So it is quadratic, which means it's got x squared in it, so there's actually going to be 2 different solutions probably. Now it doesn't have to be because it could have none, or it could just come down and touch it at one place in just one point. But we don't know that until we go check. But since we see all the answers have 2 answers, I'm thinking we're going to need to do this. So instead of doing nsolve and only getting one answer, I'm going to go ahead and graph it and trace around it and find the 2 x-intercepts. Is it already in 0 equals format? Perfect. That means I can plug my y in for the 0. Had this not been 0, I would have had to move something away to make it 0. Now it's y equals, so when I go to the graph icon and graph it, it already has y equals on the screen. I'm just going to type in 2x squared, subtract 2x, subtract 1, hit enter. Put it in trace mode, menu type 1, go trace around it, find the 2 x-intercepts. It wound up being, one was positive and one was negative. Let me see what they were. I forgot now what they were. Oh yeah, they were these 2 numbers right there to see. It was at a positive 1.37 and negative 0.333. I think both of these were rounded. I can't remember for sure. All right. Solve for x, and there's a lovely equation. Where do we go to solve a single equation when there's only x's involved, just a single variable? I can go to nsolve. So nsolve is under the add subtract screen, menu 3-1, and then go type it in, put a comma x at the end, and close the final parentheses, right? We're going to have parentheses at the beginning and the end. And when you did that, you wound up getting, oh, did I actually do this one? I guess I didn't. I'm going to have to go figure this one out. I did. Actually, y'all go put it in nsolve and get it. If you type it in right, you should get one of these answers on here. Okay? I trust you to get those. Here's another solving, and they give you 2 equations. Where do we put 2 equations? Linsolve. Just like nsolve, I go to the add subtract screen, menu 3, but I go to the second option instead of the first option because there's 2 equations. And then I hit OK for the 2 equations being used, and then type in the top equation, type in the bottom equation, hit enter, and look, they're all just lovely points. And so one of these points is going to work. I don't have that answer marked yet, so you're just going to have to go do that one and trust that you type it in right. So type carefully, all right? And then the last one over here is given f of x equals this equation, find f of -3. Ooh, there's our little shorthand for what are we plugging in for the x? See how you see f of parentheses with the x inside parentheses? Same f parentheses with a number inside. We're dropping a -3 in for the x. So if I know x, what am I looking for? You're looking for the y, so we can do that with the table. You could type in this whole equation in the graph icon. Y equals x squared plus 6x plus 12. Hit enter. Go look at the table, Control T, and see what y is when x is negative 3. Or if you're not a table person, you could do plug and chug. If you do plug and chug, you're just doing the right-hand side of the equation, and wherever the x's are, you put parentheses. So all we're doing is the math. This is plain old math screen. And what number are we plugging in for the x's? We're plugging in a negative 3. So I drop a negative 3 inside here, and I literally type this on this in the add subtract screen as one big math problem and hit enter, and it will tell you what it is. And I do believe when we did this one, the answer was 3. There we go. Y'all are getting much better at all the easy ones. We want to keep all this fresh. We got this week and next week to go, and then we'll be ready for the STAR test.